Hello! Hey, we're going to talk about graphs of sine and cosine functions today and how they can be moved around and how to graph them when they change or translated, or like to say acted upon by an unbalanced force, use all that science term. But first off, before we do that, let's look at our basic sine curve. What does it look like? So let's graph y equals sine x. First off, let's plot some points. And if we do this here, we have sine, and at 0 degrees, or 0 radians, it's 0. At pi over 6, which is 30 degrees, sine is 1/2. Right? At pi over 4, well, 1/2 is 0.5 as a decimal. Pi over 4 is square root of 2 over 2, which is 0.707. Pi over 3, if you look, sine is square root of 3 over 2, which I believe is about 0.866. And then at pi over 2, or 90 degrees, sine is actually going to be 1, which is 1. At 3 pi over 4, it's going to be, I believe, square root of 2 over 2, which will be 0.7. At pi, it's going to be 0 again, to 0. And at 3 pi over 2, it's going to be negative 1, and back to 0 at 2 pi. Now, those are some points to kind of see what's going to happen on a sine curve. And if we go to look at it, it's going to look something like that. You plot the points like that, they're going to go back down, and such like that. So it's going to make this nice little curve like that. That's what a sine curve looks like. And the big thing to note is that sine starts at the origin, or original and sine. All right? It starts at the origin. Sine starts at the origin and just goes up. Everything's positive in quadrant 1. Sine's positive in quadrant 2, negative in quadrant 3, and negative in quadrant 4. There's our particular points for it. And there's a sine curve extended just a little bit. So you kind of see how it's going to keep waving and keep doing that. And it's going to do the same to the negative side as it overlaps there. So there's those nice little pictures of what a sine curve looks like. And notice the period there is 2 pi. That's a cycle. The period is 2 pi because that is the time it takes it to repeat. We started here. Now we were back at 0 again here, but we went to negative. But then the value repeats, and think about it. It's 2 pi around the unit circle, and so therefore it's going to the values start to repeat. So what we call the period, the time of repeating, is 2 pi for a normal sine curve. All right? And notice the range. Sine is never less than -1, but never greater than 1. And the reason is, remember, the hypotenuse is always bigger than the side opposite. So that's why. That's why the values are always, like we said, decimals or fractions type of answers, because the hypotenuse is always in the denominator, which is larger than the side opposite. The only time it can be 1 is if the two are equal. Really happens on those like 90-degree marks, or is where those particular things tend to happen. All right? So